Yeah, without further ado, let's go ahead and step into this. Brian gave a wonderful introduction. I don't think I need to, elaborate on anymore. But anyway, so today, yeah, I want to talk about RCCA and basically how we adapted it at NVIDIA. I think certainly at the beginning when we came and looked at utilizing this, some of it did come out of many of the resources that are out there, Six Sigma for sure. But the one thing that kind of informed our thinking was, we kind of wanted something lightweight, right? We didn't want, at the time, and even I would argue even today where we are, we kind of look at anytime we look to build out a process, right? We're trying to make it as lightweight as possible. Even though we have large distributed teams, the idea is, you've got to be nimble, you've got to be flexible. It can't be something that has a ton of overhead, but it has to serve a useful purpose, right? It has to be something that we derive value from. So I think many, some of you certainly, I'm sure, have heard of RCCA. Some of you might have experience on different dimensions, maybe in broader terms, if you've done, lessons learned or a postmortem, or maybe you've even done some of your own granular work, whether it's Six Sigma or data mining, or, related processes, right? So my aim today is, again, to talk about how we sort of adapted RCCA as a key tool for our test production pipeline. Okay. So I'll start with the very basics. So it's important to understand the premise, some of the thinking that informs, the drive to kind of incorporate RCCA, right? In a space, especially the one where we live, where we don't have the ability to test everything, you have to make choices, right? And those choices present risk. You choose not to test something, you are essentially opening a pathway for a bug to work its way out in the field. In some cases, it could be a minor bug, but there's also the potential that it could be something that has the a harmful impact. You could just test everything, but that's not necessarily an efficient use of, time, people, resources. And actually, in our case, it isn't physically possible to test everything. If you looked at the entire matrix, the product set that we support, there aren't enough testers on the planet that we could harness to do that, right? So, the prevailing and understood wisdom is, all right, we've got to put our wood behind the arrow, and make the right choices, right? So how do you get the data that points you to those right choices? And as this graph, that I stuck in here, which I'm sure people have seen this, and there's different variants of this, the prevailing wisdom is, right, it's so much cheaper to fix everything very far, in the beginning of the pipeline than it is at the end, right? At the end, when you're finding things and they're coming in from the pipe, you're spending more on both development, the additional test, all of the things that you have to factor in, the release processes, everything, right? So catching it early, ounce of prevention is worth the pound of cure. Okay, so what is RCCA? It isn't something new. Again, our definition, root cause corrective action, right? It's a safety engineering method that you use to analyze a problem, you identify the causes, and then put in place measures that can be taken to prevent it from occurring again, right? And yes, it's not anything new. There's other acronyms and similar processes out there, whether it's the closed loop correction action plan or a closed loop action plan. Regardless, these are all basically a foundational block of continuous improvement methodologies, right? Certainly, we derived ours from Six Sigma. Lean is another, example where you'll find this. And they're all approaches that essentially can, allow for an organization to make the operations more efficient, right? By reducing variation, and obviously, eliminating defects in processes so that you don't keep repeating the same errors over and over, right? Or you're moving to a process that generates less defects in, overall, right? And, important to note, kind of one of the interesting things is, looking at the research, right, Six Sigma essentially originated Motorola in the 80s, right? And it was very much tailored towards usage on a factory floor. But it's interesting to see, I mean, obviously over time, many organizations have since applied that and certainly tinkered and tweaked, and adapted it for usage across, much of the software industry, right? So, okay, so root cause. So, first step, you have to identify what your problem is, right? Why did something happen? And the approach, again, in keeping things lightweight and simple, we kind of, our sort of methodology here was thinking in terms of the 5 whys. I'll caveat, 5 isn't a magic number, right? It isn't there isn't anything, special about it. It's just kind of meant as just a branding, right? You want to think of, 5 things, right? Essentially, you're doing an iterative interrogative technique where you just keep repeating the question why until you get to an endpoint where you can't answer that why anymore, right? Or there isn't an answer that makes sense. Each answer forms the basis of that next question. And again, you just keep going, right? And again, it doesn't mean that it has to be exactly 5. If your process takes you to more than 5, that's great. You keep drilling down until you get to that endpoint. And in similar cases, you might not even get to 5. Maybe you get to it in 2 or you get to it in 3, right? But either way, it's, you want to keep asking that question until you get to that endpoint. Just as important to note is that the purpose of those 5 whys, it isn't to place blame, right? It's you're basically trying to uncover the root cause of why something happened. And the nice thing is in doing it this way, right? You keep kind of iterating with the why. It allows your team to take these small incremental steps, right? And there's data that flows out of each one of those steps that ultimately is going to inform what you're doing for the corrective piece. So corrective action, again, pretty simple. Once you've established the root cause of the problem, you're going to take that data that you've gotten out of that process and you're going to use that to solve for preventing the reoccurrence. So it's kind of interesting when we were, talking through this, if you think about it in sort of abstracted terms, each of us does this all the time, but subconsciously, right? It's basically learning. So kind of a silly example, but, one that I think fits is, all right, if your hand hurts when you put it on an open flame, right? Root cause, I've got to burn. You don't put it on the open flame in the first place, right? Corrective action. Totally simple example. But, again, if you contrast it against the way we're approaching this, for putting it into a production pipeline, we tend to think of RCCA as institutional learning. All of this great data that we get out of this pipeline, you can kind of go back and, look at these, all the, kind of club a lot of this data together. And again, that's institutional and evolutional knowledge, right? So let me, I'll give you a case example that we actually went through when we first started RCCA. It's kind of a nice one. It's really simple, and it illustrates all these points kind of neatly. So they're, bug 1, 2, 3, 4, 5, 6, 7. Obviously, the names have been changed to protect the identities. But we had a bug. And this particular bug was a case where a user was watching a movie, and when they attempted to use a 3D application, they hit a crash. So, okay, root cause, you step down into those 5 whys. So the first why, all right, so the crash is happening. What's happening? So it turned out certain GPUs were failing frequently in this area, for this particular use case. All right, why? So stepping in with development, finding, there's module code changes that are impacting particular GPUs. All right, so why is that? Again, take another step, the next why. There's incompatibilities when you go from the upper and the lower software stack, right? So essentially the interfaces, API boundaries. Hey, weird things are happening because, here we go. Led to the next why. Well, people that are checking in changes, or at the time were putting in, the different features, they had unfamiliarity with those interfaces, right? Those API, the exchange They didn't have familiarity with the upper parts of the software stack compared to the knowledge of the actual, inside of the module that they were working on. So, certain assumptions are made, the fix or the change goes in, not taking into account, again, the whole stack versus just the module, and boom, you have an escape. So in this case, we also had a failure. We went back to our test portfolio and discovered, wow, okay, we actually don't have a use case where we've got a user that's doing these two actions in parallel. All right, that's definitely a test escape, right? So the corrective actions here were twofold. We went away and we created new test cases, right? We shored up that test area. Developers went away and figured out, hey, this, unfamiliarity with, the top to bottom software stack is not a good thing. It's not enough we can't just be familiar with, our little part of the bubble. You have to understand how these interfaces work and the dependencies between them. Because otherwise, yes, we're going to continue to check in changes, or we're going to continue to do, create features, making these wrong assumptions, right? And, this will continue to happen, and we might even see, worse results as an outfall of that. So those were our corrective actions. Okay, so the how-to process. We're going to take a step down. I've started by kind of hopefully outlining the definition, or at least, as, our version of the definition. Again, the nice thing about RCCA, and, the larger concepts, I mean, people have adapted it to, to what works for them. And so, once you define, all right, this is what we believe RCCA is, now you have to start to put the pieces in to build out the flow, right? So at the very outset, you have a high level. It's okay, we're going to do RCCA. So how are we going to do this? Well, we've got to constrain the problem set. We can't just go out there and go into our database and just go look at every single bug. That doesn't make sense, right? But we got to figure out, all right, what are we going to look at? And more importantly, how are we going to separate noise versus signal, right? So for us, the first step we took is we identified what the input pipeline was going to be. And then in hand with that, the same definition was, all right, how are we, again, what's the defined frequency we're going to do? And again, I'm going to cast this in the example of GPU software QA because, this is my day-to-day, this is the familiarity that we have. So for us, we grab all of our bugs and we do it on a weekly basis. That was the predetermined frequency. It aligns with our production schedule. We release drivers at a pretty frequent clip, certainly, a handful in a month. So the feedback that we're getting, especially as that has increased over time, we kind of went back and looked and said, a week seems about right. And so you've got thousands of bugs coming in. You've got to filter that noise. Not everything is going to be actionable. And the first thing is get the really noisy, simple stuff out, right? So again, using our example, GPU software QA gets a bug from, say, deep learning, right? Or they get it from DGX or, some other team. That's not in our area of expertise, right? Get those bugs to the teams that need to be looking at them and, addressing them, right? Those aren't in our purview. For everything else, right, that's in our stack. And we're going to categorize each bug. We're going to get it going into the RCCA pipeline. We're also going to go back and look at bugs from the previous weeks that might need further action, right? You're going to get a pipeline that comes in. Not everything is going to have every piece of information you need to be able to actually make a determination on, what it is in terms of RCCA, right? But some of those they're very important bugs, right? And it may be that we just need another data point, from the end user, or we're waiting on the results of, additional test experiments or what have you. But those don't fall out of the pipeline. We still want to address those. We want to make sure we've captured them. They're just as important. And they're just kind of in that re-review loop, right? And then lastly, again, from a high level perspective, once you're setting things into the correct RCCA, then you're driving to action or closure, depending on what the state is. And you're also reviewing the metrics that are coming out of that pipeline as a result of all this action that we're doing. And that's kind of the key important piece. And this is where, I call RCCA kind of the Dremel in the toolbox, right? Because a lot of the insights that you get inform how you go forward. You pipe those back into how you go forward for your next release, or maybe how you do your next bring up, right? You get insights that kind of tell you, we have some gaps here, or we're doing something in a non-efficient way. We could be doing this a little bit better, and here's the data that supports that observation. So again, just to kind of break this back down, I talked about process step one, using our NVIDIA example, obviously. So a bug comes in, I filtered out the noise, and I assign. So here, I'm kind of focusing on, there's many more categories, and I'll talk about those later on in the slide deck. But the ones that we tend to really, very much zone in on are these 6, right? So we're looking to see, all right, is it a test escape? Is it a coverage escape? Is it a customer release escape? Is it a release planning process escape, right? Both the release and the customer release, those aren't bugs that are in our purview, but we have the inputs to be able to change, change actions to ameliorate things on that front. So again, there are things that we look for. The insufficient info ones, I had mentioned that, all right, we don't have enough data to be able to make that determination. All right, so that goes into a holding pattern. And then the last one, invalid software driver issue, that basically closes the loop on that bug. So if something's an invalid software driver issue, that's usually something that it's not it's not in our court, right? It might be an application issue or just something that's just not germane to us. That bug, that gets closed, that gets moved out of the pipeline, right? And we go after everything else. So what does the process flow look like? So if I'm a new person that's kind of coming into the team and, okay, all right, we all do RCCA, and how does it look? I've kind of outlined some of the very high level steps, but drilling down a little and getting, a little bit more precision focused here. Pretty simple, right? As I said, you've got your incoming data, and that's in 2 pieces. You've got the new bugs that are coming in from the field. You've also got that list of backlog that, you've been tracking, the issues that we couldn't move on because we didn't have the right data. You're going through those to see if the state has changed, right? So that's your input. Then you're going through the assessment state. So everything that you can set in moving through the RCCA pipeline, that's what you're doing, right? You're setting the states. The insufficient info loop, right? If I've got data available, yep, I can move on those. Hey, if there's no data, that remains on my, to be dealt with list, and I'm going to revisit that again next week. Hopefully the state has changed. There's the actual RCCA, right? So, hey, is my bug a test escape? Is it a coverage escape? Is it a release customer escape? Do I have to assign this for action? I'm setting the baton to the person who's now taking it. The driving to closure and the actions, right? So if it's a test escape, I may be adding or modifying test cases. If it's a coverage escape, I might actually be adding a config right off the bat, depending on the severity of the issue. There may be larger scale efforts, right? If it's a really egregious customer or release escape, right? We're having a conversation with the release planning team. We may need to fix something in the software development lifecycle process, right? To make sure that, we don't have these holes. And then there's the higher level order, the big ticket items, right? We're looking at the metrics. We're going back, and kind of taking that snapshot. All right, let's do the look back, maybe the last release, or going back all the way to the beginning of the year. Do we have hotspots for test escapes or coverage escapes? Is there a particular area or module or test block where we're seeing a lot of this, and that's indicating that there's something going on, right? And we need to have that larger conversation with development partners, where we have to, maybe do a wholesale test plan review, or really go back and shore things up. Or maybe we need to pull, the SDET testers in, and okay, we need some more API testing or something like that. So I just showed you the process flow for RCCA, and it's, it's interesting. So if you look at that as part of, again, the whole, everything that we do day to day, right? Your entire toolbox. So we're doing RCCA week to week, every single day. And the results of what we're doing there folds into our testing, right? So, if you look at, the bottom arrow kind of shows you, right? Our normal production test cycle, we're starting with a sprint, we move forward, we get into integration, and then we're in production testing, right? And production testing, we're getting into our GA releases, and then you're getting into sustaining. So in parallel with that, RCCA is happening. We're getting the issues from the field. We're assessing those, things that are becoming test escapes, right? We're closing those out. If we're creating or modifying test cases, that's getting done right away. And that is folding right into, it could be, you might be catching it between the sprint and production. You might be catching it between production and sustaining, right? And then it's getting carried forward to the next release. That, all of that informed learning, all of those actions that we're taking based on those determinations and the higher level metrics, that's all flowing into our production pipeline real time. Okay. So details. And again, keep in mind, this is, kind of like a case study. Well, it is a case study. It's, our specific example here. And this is kind of getting down to the 10-foot level, right? What all these pieces really look like, from a granular perspective. So, I talked about, made a determination. We kind of look at the bugs that are incoming on a, the weekly was the right frequency. And, the data has proven that, right? Weekly really is kind of the right granularity. For your input, it's important to identify your sources. For us, when we started this process, it's a mix of sources, but again, it's everything that represents bugs that are coming from the outside field, with one exception. So you've got, it could be a customer, it could be an end user, it could be a reviewer, a press journalist. It could be one of our OS partners, right? Microsoft has been pretty instrumental in giving us a lot of feedback that has gone through RCCA. Certainly on their side, they have their own processes that kind of do the same thing. So they're very familiar with this. Could be one of our Linux distro partners. ISV bugs, so independent software vendors. So any of the application partners we work with, and we work with many of them. I will say ISV bugs are typically one of the areas where we see a predominantly large influx and balance of bugs that come through, through RCCA. And technical marketing. So this was the caveat, right? Technical marketing isn't an external source, right? They're an internal part. They're our team. But technical marketing is charged with the responsibility of kind of doing that last step review before we release product. And it doesn't matter whether it's hardware or it's software. They do the virtual review and come back with data saying, okay, I am doing this from the perspective of a customer sitting on the other side, and here's how it looks, and here's the issues that I found. So again, they aren't an external, customer, but their data is valuable because they are one step away. So we tend to take those and put those in the pipeline, because even though, it's great, we found it internally, and if it's a really egregious issue, we can kind of turn around and, if we need to make that part like a last minute deliverable as part of the release, it's great. We have that ability, but it's late in the pipeline, right? Going back to that first, chart that I put up, the diagram, you're finding it late. It's a little expensive to be finding at that point, right? And you would have wanted to have caught that far further left than we have, right? So hence, our kind of decision that, process that we made and saying, yeah, technical marketing, let's treat them as essentially like an end user customer, right? Because that still is, it's not a comfortable spot where we want to be finding these, these escapes. So, we identify the sources, we set up our filters. So, one thing I'm going to talk about is, it's one thing to have the process, but process is only as good as, if it's an incredibly manual process riddled with a lot of overhead, that becomes problematic. And certainly, For a team our size with the products that we support, our overriding ethos is, we want to make sure that we're automating the end-to-end workflow as much as possible. You want to keep it lightweight, low touch, and keyed off of the tools that we're using consistently, right? So for us, everything starts from the bug database. So again, that input pipeline, you don't want to be manually just going through there's thousands upon thousands of bugs that come in a week. You need that first step shortcut, right? So we're able to essentially set up keywords. So anything that comes in from that external pipeline gets tagged, and we can pull a custom watch list, and that's just a push button, right? So instead of going and manually cobbling it, right, you go in, you push your button, and you've got your weekly updated bug list. The nice thing too is that bug list is visible to a wide cross section. So it isn't us just looking at it, the planning teams look at it. And more importantly, so does the development team. Excuse me. The development team is a very crucial part of RCCA because in 90% of these issues, we rely on them to help inform our root cause, right? Because they're the ones that typically, especially on the more complex bugs, they're going in and from a code perspective, okay, here's what's going on and here's what's really happened. And so, that helps inform our decision-making process. And so everybody has to be aligned and looking at the same set of data. So, that's how it's been structured. We also, obviously, there's reporting that goes out. We ended up building a portal that houses not just the bug list, but most of the data mining that we do based out of this process lives there. And it's pretty extensive. We have the ability to do very drilled down cuts, very specific cuts for whoever, like whichever business unit wants to see it, or even module unit. And so that flexibility is really good, right? Because you want to keep a team flexible and nimble enough, right? And having the right set of tools so that a process like this, there's a lot of work to do to make the changes, to make sure that you are shoring up the gaps. And the easier it is for you to get to that data and get to the ground running, the better off you are. So, lastly, as I mentioned here, when we send out and we set up this reporting, we segregate it by business unit, right? So it isn't everybody's looking at this humongous pile of all the RCCA issues, because that would be incredibly noisy. And again, the first question you'd get is, can I just see mine? And as I said, the tools have advanced to the point where, at least on the portal, it's not even just by BU, but say, I'm somebody in the driver stack and I'm working on a particular module and I just want to see my module RCCA. Yep, we have that cut of data. We have that whole pile of information. It's super easy, and there's no gating factor standing in the way of somebody just getting that data and being able to chase it down, and take the appropriate actions on it. Okay, so triage. Your bugs come in, you want to sort and assign, right? You're keeping the noise low, you're collating all the misdirected bugs to the correct area. We set all the bugs to the appropriate state. We assign the bugs for action to the right person. One of the things that, I'll make the distinction here, because I know, again, the way we set up the process, right? I kind of outlined this here at the last point. We have owners. The way our team is structured, we have a pretty extensive team that's globally distributed. We have the concept of test block owners. We also have the concept of subject matter experts that bubble up to the test block owners. And what this allows us to do is, again, you can kind of delegate, you've got owners everywhere. It isn't just one person that is sitting there and doing all of this assigning and all this determination, right? It's the right people that should be doing it. It's the people that understand and know that particular module area and can make that call in the most effective way possible. So that, again, setting this process up the way we have and tying it to the tools has allowed us to delegate, and that gives us the efficiency, but it's also scale dependent. So, on the flip side, I would realize that, again, some teams, depending, in different companies or different teams, depending on the size, you may not have the luxury of being able to do that, right? But for, a team that supports the breadth, again, of products and releases that we do, the most, going to ground, the most important thing is figuring out, okay, how can I scale this, make this efficient, right? And make this process as lightweight as possible. So the right people are getting into, the areas that they have to understand what to do. They have the tools they need to do, and we keep this moving forward, right? And it works as a tool versus this is overhead that we constantly have a backlog on that we have to address. Okay. Root cause. So, we covered this again at the beginning, but, in terms of just internalizing this as a practice, you want to determine root cause to the best of your ability, right? You want to keep it simple. There's a handful of questions, you keep in mind. And again, it kind of all stems from that whole, like, what's the soul of RCCA, right? And the questions are everything from, do we have test cases in this area, regardless of whether we've actually got the config or the platform? Do we actually have the test cases and maybe we chose not to run them, right? Was this a bug that was previously reported but not fixed? We've definitely seen issues like this, right? We actually surfaced an issue internally, but this in the release process and the software development lifecycle process, as a result of it, we decided that we were going to ship with that issue, and lo and behold, it actually came in through the endpoint of the pipeline. Was the testing valid, right? Did the customer have access to untested software? Or would we have actually found this bug if we had tested it, right? So it's interesting to note, our processes in GPU software QA have matured to a point where, I'll be very honest and forthcoming, customer plan escapes are not something they're very rare to see. Our drivers really only do get released and ship when they're ready. We have very few exception cases where drivers are being shared, where a customer is actually working on them, earlier than they should be. However, while that may hold true for our group, it's not necessarily the case for other groups, right? And this kind of gives you an indicator, a very strong indicator of what products are in their nascency versus those that are established and more mature, right? Because those that are obviously at alpha and beta, they're going to have a disproportionately higher amount of customer plan escapes, right? Because they may be working with lighthouse accounts like, hey, try this. So there's all these things coming in. And, QA has, may have the test cases to cover it, but can't even get to it because they're sort of on the forefront, right, from where they should be. So again, it's informative, right? In that case, you kind of look at this and say, oh, all right, you've got a high degree of these customer plan escapes, you're letting stuff out, and, are we at a point where we should think about locking processes down such that, we're changing the timeline for when the customers are getting the product to when it's really ready, versus, the customers getting it maybe at the same time as QA, right? Which is not a situation you want to find yourself in. So, and then lastly, is the customer doing something that's unsupported? An example field that I have here, so, I talked about how, we plumb these processes into the existing tools, right? So this is the actual RCCA field we have as part of our NV Bug system. So NV Bugs is our bug reporting system for all of NVIDIA internally. It's a homegrown system. We built it from the beginning. It's pretty extensible. It's pretty powerful. And, again, the cool thing to see is, when we first started and defined RCCA, we knew, everything is going to flow from the bug. So we have to kind of go in, and that's the starting point. We have to make it so that it's just an automatic, you pick everything, all the data is there, it's all captured. We're not losing any of this. We can mine for historical data, it's accurate, it's synced, it's up to date. And over time, many of the other teams have now utilized this field and have, not only have leveraged it, but they've, gone in and made their own changes. Again, most of them tend to use the fields that we've set up, but many of these teams, whether it's hardware or architecture or operations, need their own flavor, right? So they'll add in some cases, I'll talk about this, they may add their own section, or, an add-on to their own process. the main field that you see here that is coverage test escape, this is where you're actually setting the RCCA state. So that's where a lot of the change happens, because, people will add, fields to that pick list that's particular to, say, their business unit or product team. The rest of it, the way we had structured this, again, we're trying to be simple, get the base data, the things that we can mine, generate the automatic reporting from. So, again, RCCA classification obviously is the first and foremost, because from that everything flows. But, you have your RCCA owner, everything about test cases that get changed. Maybe it's a coverage escape type. Certainly another key area, where did this particular RCCA happen? What's the test block or the functional area? Or if it's required by another team, right? There are data fields where you can basically, talk about how you arrived at your root cause analysis, your corrective action, a bunch of other fields for adding, related notes. On the right-hand side, so these sections came out after, we had done our initial design and implementation of the RCCA, but the devs realized that, hey, because they're an important part of this, we've got to go ahead and rig up, our own RCCA field as well, right? So they kind of, took a lot of, in the same measure, took a lot of the fields that we had, but obviously appropriated for their use, their usage. They have their own RCCA owner. Their root cause is going to look different from ours, so they have a field to be able to do that. They're more interested in following whether the test case, is an automated one or not. Obviously, affected component maps to the area, for us, the escape, or the escape affected area. Sorry. And then, they have more fields that are germane to them, such as preventative action. Hey, if there's a test action, and their corrective action plan. And then lastly, we also have the security team, who's very interested in RCCA. So security bugs are a special beast. They're highly important. They have the ability to force hot fixes and, certainly out of band releases. And in terms of how we track, security brings its own challenges, right? It isn't just, we fixed that security issue. There's a lot of documentation that goes along with it, right? Because the paradigm for tracking, monitoring, and reporting on security is very deep. It's very thorough. They have to have a lot more supporting data and documentation. So for them, the fields that we had weren't quite enough, right? For them, we go through the standard RCCA process, but then they kind of, take it a level further and, okay, so, you found a security issue. Are there changes that are needed in one of these 5 areas, or maybe all 5, right? Do we need to change our training processes? Do we need to change how we define requirements? Maybe we need to change how we do architecture and design, or even our coding practices, or, verification practices. And they kind of added an extra step here where, it's not just, okay, here's the affected area and what we had to change, but also we're going to file a bug to track that and make sure that action got closed. And again, this is all part of having to provide that supporting documentation. Okay, we recognize there's a security vulnerability. Here are the changes we understood that we have to make. And by the way, we've tracked those all the way to completion, and we have closed them out. So we really have addressed the security vulnerability.
Hey, Martina, we've got about 3 more minutes left, and then because we're going to need a little bit of time for transition and then to the next talk. So just giving you a heads up.
Okay, thank you. All right, so I'll go through this real quick. I only have a few other slides left. So the available classification choices, again, I showed you the field. There's many more choices now. When we first started this, we started with 8, and now there's many more. The fields in orange, these are the ones, the categories that we lean into and data mine the most. Many teams obviously, continue to utilize this and data mine. This will actually expand over time. Again, just another step through what they mean, test escape in progress, coverage escape, release planning. I'm going to jump to this. I think this make this the last one, because this is kind of encompasses the, so again, sort of finishing up this, leveraging your process and tool set, right? So again, the ethos, you want to instrument the process into your existing tool sets and automate for end to end. And anything that ends up in the manual side, it's unworkable, right? So as I had mentioned before, our two most commonly used tools are the bug database and the test repository. So we knew when we built this process, we have to hook that into those most common touch points. So we did that with NV Bugs, but we also did, we did a hookup to the test repository, right? And the idea is that we want to move to a state where besides doing triage, your most common inputs are just going to be either auditing or tracking. That's it. And even just as an aside, on a interesting note for triage, one of the things that we started to look at is building out deep learning models to do even that. We have built deep learning models in test quite successfully. We've deployed many. We're bringing more online. We've implemented deep learning in an automatic bug filing tool that's proven to be very successful. And the next step, again, is kind of taking that, being able to leverage that and apply it to triage, because again, that's the most manual piece right now. So again, if you can build a model that's pretty successful, that has a high success rate, that's going to remove even more of the remaining manual pieces that we have left and make this a complete end-to-end automated process, right? So just two things to note. The way we set this up, when we identify test escapes, the way we set the field, when we're working on it, it's test escape in progress. We go off, we work with the developer, we create the test cases, we're doing all the work in dev test to actually get those in. These end up getting issued IDs. And then when we go back, we can go and flip that flag in NV Bugs and tell it, okay, it's test escape, which means, hey, it's not only we identified as that, it's done. We've actually made the test cases. The NV Bugs tool can actually go into the dev test repository, find those IDs, and then pull all that information into the bug report. So anybody looking it up can see, yep, you identified this as test escape. By the way, you fixed it. You shored up the test plan area. By the way, here are the tests that were added. Yep, this has been closed, covered. I have confidence that this is no longer a gap. Coverage escapes work in a similar way, except you don't have that second step closure field, but we're doing the data mining, right? And we're looking at that very closely because, again, if you start to see sort of a hotspot, right, escapes are happening in a particular test area or on a particular config, we know something's missing, right? It could be, there's some version of the OS, we're seeing lots of issues come in on this, and that's not part of our standard test matrix. Hey, we need to sit down. Let's make sure that for the next release, we add that, right? So that it's covered, so that we're not missing these things and they're not getting out to the field. Okay, last slide. Hopefully I'm squeaking in under time here. So everything starts with the metrics and data, right? Everyone owns a piece of the corrective actions. And even though, as I said, I talked about the 6 categories we focus on, and out of those, our main focus and where the brunt of the work is on the test and coverage escapes. The other buckets are important too, right? Release planning and customer escapes are just as important, because if we have to improve our overall software lifecycle practices, that data is there to help underscore that conversation and help move that forward. Lastly, RCCA is only as good as our thoughtful inputs. So if we shortcut, we make hasty determinations, we kind of tend to put things to the back burner and build up a backlog. That data isn't going to lead you to the actions that you need to take, right? So, we try to also exercise some measure of auditing so that we're making sure that we're holding true to ourselves. We really are making the right calls on this data. And overall, we've kind of boiled it down to, I think the guidance we give everyone, our soul of RCCA is, you boil it down to the one thing. It's when that bug comes in to your pipeline, hey, is there anything that we could have done internally? Is there a test case that would have caught this issue, right? And that's a pretty binary thing. And when you fall outside of that, it's a lot easier to kind of, traverse through all the other categories and, find the right home for that bug. But that's the big, sort of binary sort, as it were. So that's all I have. And I'm more than happy to answer any questions.
Unfortunately, we don't have time for questions, but you are contactable via basically that link right there, as well as presence online in the conference there. But did a lot of information. This is one of those decks that it's going to make sense to go dig into later and go, oh, there's even more detail there. You put a lot of work into that, and it's a tried and proven methodology that we can glean from. So very, very nice. Thank you for answering. One of your later slides covered the coverage escape question. So we got to that one. So I think we are in good shape.